Bismillahirrahmanirrahim. Dear students, in today's lecture, we will discuss an important application of a stack in a function called recursive function. Ladies and gentlemen, a function that is defined in terms of itself is called a recursive function, and this property is known as recursion. The recursion may be implemented by means of a stack. This function postpones certain steps of processing until other conditions are fulfilled. The stack also manifests such property through LIFO philosophy. Some of the problems that apply recursion are factorial function, Fibonacci series, and Tower of Hanoi. Dear students, the recursive function must exhibit 4 rules. The first rule in this regard is the base cases rule, which states that you must always have some base cases which can be solved without recursion. Making progress is the second rule, which narrates that for the cases that are to be solved recursively, the recursive call must always be to a case that makes progress toward a base case. The designing rule is the rule of recursive function, which assumes that all the recursive calls work. Finally, the compound interest rule clearly states never duplicate work by solving the same instance of a problem in separate recursive calls. Ladies and gentlemen, some of the problems where the problem structure lends itself naturally to a recursive definition include factorial function, Fibonacci series, Tower of Hanoi. Having a recursive problem is a cue that a recursive solution should be pulled out of the toolbox. An instance of a recursive data is a file system found in every laptop computer. A file system consists of named files. Some files are folders containing other files. So, a file system is recursive. Folders contain other folders, which contain other folders. Finally, at the bottom of the recursion are plain non-folder files. For instance, the java.io file is Java library file system. It is a recursive data type because f.getParent file returns the parent folder of a file f, and f.listFiles returns the files contained by f, which is an array of other file objects. Dear students, depicted in this slide is the recursive definition of the factorial function. You may have noticed that the n factorial returns the value 1 if n has 0 size. On the other hand, if n has some size which will be represented in positive integer value, then n calls itself after decreasing once, and this process continues toward its base case from where it accomplishes the n factorial computations. Dear viewers, this slide sketches the recursive function of a factorial algorithm along with its non-recursive counterpart that deploys iterative algorithm by containing the for loop in its structure. From this slide, it is evident that the call to recursive factorial function postpones its computation until the base condition is met. From there, it starts returning the values as is the case in this diagram, where 3 factorial returns the value 6. Dear viewers, the diagram depicted in this slide further explains the concept of LIFO when the stack is deployed for the computation of 4 factorial through recursion. You may have noticed that every time the fact function is invoked, the values are pushed into the stack until the base value arrives, from where the sequence of pop operations is performed to get the final value. Ladies and gentlemen, 2 common reasons or situations where recursion is imperative are: first, the problem is naturally recursive, for instance, the problem of Fibonacci series or the problem of Tower of Hanoi. Second, the data is naturally recursive, for example, the file system in our laptop. Another reason to use recursion is to take more advantage of immutability. In an ideal recursive implementation, all variables are considered final and all the data is immutable. The recursive methods are all pure functions in the sense that they do not mutate anything. Moreover, the behavior of a recursive method can be understood simply as a relationship between its parameters and its return value, with no side effects on any other part of the program. This kind of paradigm is called functional programming, and it is far easier to reason about than imperative programming with loops and variables. The iterative implementations, by contrast, have non-final variables or mutable objects that are modified during the course of the iteration. Dear students, the recursion manifests a few of the advantages, such as the recursion is very flexible in data structures like stacks, queues, and linked lists. It is better to solve some problems that are extensively recursive, for example, the problem of Tower of Hanoi, which will be discussed in the next lecture. Besides these, some data, for instance, a file system found in every laptop computer, is also recursive in form and could not be retrieved without recursion. The length of the program can also be reduced while deploying recursion. Ladies and gentlemen, the list of disadvantages of recursion is big because the recursion may take more space than an iterative solution. Building up a stack of recursive calls consumes memory temporarily, and the stack is limited in size, which may become a limit on the size of the problem that the recursive implementation can solve. If the programmer forgot to specify the exit condition in the recursive function, the program will run out of the memory. Recursion is not efficient in execution speed and time. Iteration should not be used where an immediate response is vital for proper functioning of the program, such as the case of real-time systems. Avoid recursion in programs like compiler that are executed hundreds of times. A recursive implementation can go wrong if, firstly, the base case is missing entirely, or the problem needs more than one base case, but not all the base cases are covered. Secondly, the recursive step does not reduce to a smaller subprogram, hence the recursion doesn't converge. A buggy recursive program fails faster. Therefore, these must be debugged. On the bright side, an infinite loop in an iterative implementation usually becomes a stack overflow error in a recursive implementation, which is not as critical as its former case. Dear students, in today's lecture, we explored a very important application of the stack called recursion. We discussed in detail the problems where stag is imperative to be deployed. For further details and studies, you are hereby advised to consult the 6th chapter of Data Structure by Lipschutz. Till next lecture, stay home, stay blessed, happy reading.